Good morning and welcome to chapter 12. All right, our final chapter of the year. We are going to take a look at vectors. If you watch the minute video I posted with the clip from Despicable Me, hopefully you can see that a vector has both direction and magnitude, as the villain says in the clip. So magnitude is represented by the length of the vector. Okay, direction is how it is oriented. Okay, the tail and the head, it starts at the tail and it goes to the head. Now, you might notice with these symbols, we have three vectors here. They each have a different magnitude, different direction. The symbol looks much like a ray, except you'll notice it just has one letter. It's different than a ray in that in geometry class, a ray, it starts at that point, it goes on forever in that direction. Where a vector has magnitude, meaning it only goes a certain distance. Like A here has a higher magnitude than B because B is shorter. So if we look here, which one has the smallest magnitude? So either A, B, or C. Hopefully you can see B is the shortest in length, so it has the smallest magnitude. Okay, now which one has the largest magnitude? We look, A is clearly the longest. Now they also have direction. Think back to that unit circle. So to the right, we start from the origin to the right is 0, so this one will be more than 0, less than 90. This one will be more than 90, less than 180, somewhere in there. This one is more than 180, less than 270, somewhere in there. Okay, so direction of 240, it has to be vector C. And then meanwhile, the last one, direction of 50, 50 is up in quadrant 1. We know that has to also be vector A. So now, in my opinion, vectors are pretty easy. We just got to kind of discuss them, what they are. So if we look here, the x and y values of the terminal point of a vector when the initial point is at the origin are going to be written as a comma b. So if we look here, if we draw this vector with an initial point at negative 2, 6 and a terminal point at 3, 2. So remember, initial, like your initials of your name, the first letter. So that's our starting point. So negative 2, 6 right there. And it goes to 3, 2. So let me mark that right there. And it goes between those. And at 3, 2, oops, that's not the best line. At 3, 2, we're going to have an arrow. Okay, so that is our vector. Now, if this started at the origin, if this was the origin, whatever we found would be AB. So we can write those down just simply. If that was the origin, we'd count to the right and down. It would end up somewhere over here. Now, ours does not start at the origin, but we can still act the same. So imagine it started here, and let me zoom in a little bit. If we went over, so over 1, 2, 3, 4, 5. So to right 5, we know that's a positive 5. And then down 1, 2, 3, 4. So down 4 we know is negative 4. Okay, so that is how we write it. Now hopefully to find our magnitude, magnitude is like that distance. Okay, so we can figure that out using Pythagorean theorem, a squared plus b squared. So this was the distance of 5, this was the distance of 4 in the negative direction. All we got to do then, so if a squared plus b squared equals c squared, we can do 5 squared plus 4 squared will equal c squared. So 25 plus 16 will equal c squared. 25 plus 16, that's going to give us 41, which equals c squared. We take our square root, and c will equal the square root of 41. Now we can just leave it like that. If you wanted, you could find a decimal. It's like 6.4, somewhere around there. We know it's more than 6, less than 7, because 6 squared is 36, 7 squared is 49, somewhere in there. But that's good enough for now, square root of 41. You can reduce it if possible, but 41, we're good. We don't need to do anything. So let's look at the back now, and sometimes we won't have a graph. On this graph, it was pretty easy. We could just count it over 5, down 4. Okay, sometimes that's not the case. So in that situation, just take whatever the terminal point is and subtract the initial point. Now you're going to have to do that for both the x and the y component. So if we look at this first one, so we start with our terminal point, so we'll do x first, so -1 minus that -6. If we subtract a negative, we actually add it, so that gives us 5. And our next one then, 1 minus 3, that would give us -2. That's basically saying from the initial to the terminal, there's a change. It's +5, 5 to the right, which -6 to -1, that makes sense. From 3 to 1, it's a change down 2, so we get that -2. So you always start with the terminal point, subtract the initial point. Now I just need to write it. So 5, -2, let's write that as a vector in component form there. Okay, our next one, same thing. Start with your terminal point. And remember, x goes with x, y with y. So in this one, 3 minus 1, that's going to be 2. -2 minus -7, that will be 5. So 2 comma 5, 2 to the right, 5 up. Okay, and we're done. That's all there is to it in component form. If it's on the graph, you can just count over and up, or you can use this method as well. Okay, the final one, and we already talked about this, but the magnitude of the vector. Now, first off, this will need to be a positive number because it's not talking about the direction here. This is just the magnitude, how strong it is, how long it is. So all we have to do is you find that a and the b. Now remember, the a and the b, if we go back in component form, that's what we get as our answer in component form. So before we can do this, we need to do what we've just done up here, and then we can square each of those and take the square root of that, as that's just a modified version of the a squared plus b squared equals c squared. So let's start off with our terminal point x, so 5 minus 2, that will give us 3. Then 9 minus 7, that will give us 2. Now all we got to do, it's the square root of 3 squared plus 2 squared. So the square root of 9 plus 4, and our final answer, the square root of 13. So that would be our final answer. And we'll do one more. This is the last one for the day. Once again, start with your x terminal terminal point. So -2 minus 4, and for the y, 1 minus 9. So that gives us a -8 for the y, a -6 for the x. So if we square those, remember, if we square a negative, it becomes positive. So that'll be the square root of 36 plus 64. We add those together. Square root of 100, which is, whoops, I don't need a square root anymore. Square root of 100, hopefully we know, is 10. So the magnitude of this would be 10. And that's our final answer for the magnitude. And so that's all I have for you. If you haven't done the test from last week, you got to get that done. Okay, we're coming to the wire, I know, but please get your test done so your grade doesn't drop. And finish out the year strong. Let me know if you have any questions. There's a Delta Math assignment for today, so let's get that done. Have a great day.